Oh yeah, applications of linear equations, word problems. Yeah.
Correct. That's right. Got it. Thank you. Okay, so today we're going to do some more applications. Different type of applications. We're going to see how to use equations to solve some ratio involving problems, some ratios, and some percents as well. So let's first talk about ratios and their relation to proportions before we do some percent. So we're going to involve equations again in everything here. Basically, we have some applications of equations. In addition to the word problems we saw last time, consecutive numbers, and so on, we can also apply equations here to solve ratios and proportions. All right, so let's start with ratios. So when we talk about ratios, we simply refer to some numbers, some quantities that are related, related numbers. For example, when you see at a store or supermarket, for example, 3 items are worth, for example, let's say $7 or $8. So 3 for 8. So 3 for 8 is what we call a ratio. So we can say 3 for 8 or 3 to 8. I mean 3, not 4. 3 to something. So a number related to something else. So 3 to 8, we can also use an arrow, say 3 to 8 like this, or use the actual symbol of a ratio, just these two dots, colon like this. So I say 3 to 8. So we say 3 to 8. That's the symbol for ratio. You may also use fractions like this, or division like this, or an actual fraction like 3 over 8. So all these basically mean the same thing. They all refer to the same thing. So we call that ratio. So a ratio is basically, you can say, related quantities. Could be two quantities or could be more. Related quantities. So two numbers or more that are related. They're not just random numbers. There is a ratio or a relation between them. So we call that ratio. So it could be like this, like I said, 3 to 8, which means if you want to buy more items or less items, if the number of items changes, the price also changes. So you could buy more or you could buy less. So if one changes, the other one has to change accordingly. For example, 3 items for 8. If you want to buy, for example, 6 items, how much does that cost?
16.
Would be 16, that's right. So if we double the number of items, we gotta double the price. So it would be $16, for example. So everything changes proportionally. I'm going to talk about the proportions in a moment. So if one changes, the other one has to change proportionally. So related quantities, it could be 2 quantities or it could be 3. It could be 3 or more quantities. For example, when you cook, for example, so you use ingredients. You could use 2, 3, 4, 5, whatever, however many ingredients. Let's say, for example, you use 3 ingredients. And let's say 5 of something, 2 of some other ingredient, and maybe 3 of a third ingredient. So this is, for example, the recipe of some whatever you're making. So let's say 5 eggs, 2 cups of flour, 3, for example, spoons of water. Just random, some ingredients. So this, for example, to make one cake or whatever. So if you're going to make more, you're going to change all the other ingredients proportionally. or accordingly. So if you increase the number, if you increase the amount here of this ingredient, the other two have to also change accordingly. You can't just add a lot of flour without adding the other ingredients. So everything has to change accordingly. Or in case of, for example, salt. If you add in salt to a recipe, you gotta increase the other ingredients. You can't just add a lot of salt and not add the other ingredients. You can have, of course, some bad tasting food. So let's say this is the recipe to make one thing, one pie or one cake or whatever. So let's say if I want to double this, what happens to the other ingredients? If I double this ingredient,
You doubled as well.
gotta double the other one. So if this is 10, this is gonna be
4,
4 and
and
6.
6.
6.
That's right. So everything basically changes proportionally. So we times everything by 2. Same way here we doubled. You may triple, multiply by 5. So each one basically is a ratio. A ratio could have 2 numbers, or you could have more numbers. And if the ratio changes, if we change one of the quantities, for example, here one of the ingredients, you got to change everything else proportionally. So proportion basically means to change whatever ingredients or dimensions accordingly. Same way, for example, if you have a picture, if you have a small picture and you want to make it, for example, 1 by 2, you want to make it a poster. So if you increase one side, basically we double this side, you got to double the other one to 4. Otherwise, the picture will be distorted. It's not going to look good. You can't just increase one side. You're going to extend someone or some objects. You're going to deform the object if you don't change everything proportionally. If you increase one side, you got to increase the other one, and so on. So proportionally, just like zooming in and out of something. When you zoom in and out, the quality or the item quality stays the same, the form of it, but the size changes. So that's basically the idea of ratios and proportionalities. So let's see how to check. Let's see now how to check whether some ratios are proportional or not. So based on what we just said, everything has to change in a certain way. So proportions. So again, let's take a random example. Let's say 5, 2, 3, whatever this is. Could be items and prices, could be ingredients. In general, it's 2 quantities, so 5 to 3. What if we have, for example, 10 here? 10 would be to what? So 5 to 3 is the same as 10 to
6.
6. That's right, because it looks like this ingredient doubled. This ingredient or this quantity doubled. Basically, we times it by 2. So you get times the other one also by 2. Again, that's what we mean by proportional. Both have to increase the same way. So this will be, so 3 times 2 is 6. So these two together, so we have a ratio and another ratio. Together they form what we call a proportion. So a ratio and a ratio, they form a proportion only if we cross multiply them and we get equal quantities. Let's see how to do that. So if two ratios are proportional, that means if you times them, if we cross multiply them, we should get the same value. So 5 times 6 should be equal, or must be equal. That's right, must be equal to the other multiplication. So this way and the other way. So be 10 times 3. So this is 35. 30. This is also 30. So these are equal. So that's how you know the two ratios are proportional. The two ratios are proportional. So we could check simply by multiplying or cross multiplying. So you see here the ratios. are proportional because the cross multiplication is equal. Let me give you another example. Let's say 8 to 7 and maybe 8 to 11. We don't know yet. These are two ratios. We don't know if they're related, if they're proportional. It means one of them is based on the other. So to find out, what do you do again to find out whether these two are proportional or not?
Multiply.
Cross multiply. That's right. So we're gonna multiply this way. We're gonna see if that's equal to the multiplication this way. So 3 times 11. Again, we say is it equal to 8 times 7. So this is 33. And this is 50.
56.
That's right. As you can see, they're not equal at all.
It's not equal.
All right. So what do we say about these ratios?
They're not proportional.
Exactly. So they're not proportional. These are proportional, but these are not related. So for example, if you buy 3 items for $7, it is false to say you can buy 8 items for $11. This is baseless. This is not true. So we say not proportional. So this is not something to go by. Or if you're cooking, for example, you can't rely on these ingredients because this is going to change or distort whatever quantities you have. So not proportional. Okay, so that's how we check the proportionality. Okay, again, if one thing changes, the other one has to change, the other side or the other thing has to change proportionally, double both, triple both, not just random. So this is random here, as you can see, it did not change proportionally, and we check that by cross multiplying. So that's how we know it's not proportional. So basically, we just have to cross multiply. Now, let's see how to solve proportions. Sometimes we have proportions like these with a missing number. Maybe here, there, or there, you have X in one of them to be complete. So you can call that finding missing quantities. Okay, finding missing quantities. So you may have, for example, a ratio that looks like this, 5 to 2. You'll have another incomplete ratio. For example, let me say 7 to X. So here, we're not trying to check whether they're proportional. So it is assumed that this is a proportion. So for this to be a proportion, what should the value of X be? That's the question here. So we need to find the missing quantity. So these two ratios are proportional. So 5 to 2 is the same as 7 to what? So it's not always this simple. For example, here we can see that we doubled 5 into 10. We doubled the other one. Here, change 5
Multiply
into 7.
7 by 2 and divide it by 5.
That's right. That's how we
2 times 7 divided by 5.
Okay, that's what we will do to solve it. So here we don't have a clear ratio here. It's not 5 times a specific number. And we can't add. We don't just add, for example, here we added from 5 to 7. We can't say plus 2 here and plus 2. That's not how it works. So proportions, we multiply, we double, or we divide both. We either divide both sides by the same number, or we multiply them by the same number to get something proportional, not by adding or subtract. So to find a missing number in a proportion, so we need to cross multiply. Here we cross multiply to check the proportionality, but here to solve or to find X, cross multiply, so we can turn this into an equation. And solve for X. So we're going to multiply these two together. So again, 5 times X. And again, we're not checking. We know for a fact it's a proportion for a certain number X. That's what we need to find. We're going to find a certain number. So 5 times X. 7 times 2. So 5 times x is 5x, 7 times 2. So 5 times x is 5x. And of course, 7 times 2, that's 14. And this is an equation, again, just like so we learned how to solve equations in the past couple of classes, so we can apply them. We applied them last time, we apply them also today. So let's solve this. There is one step here to solve this for x. What do you do?
Divide 14 by
Divide by 5.
Exactly, so we're going to divide by 5, divided by 5. X would be 14 by 5,
2.8. Oh,
by 5, which we can
Yeah, 2 point.
reduce it first, if possible. You can write it as a mixed number, you can write it as a decimal. It all depends on what you're doing. For example, if this is about money, so you would want this to be
a decimal.
decimal with 2 decimals. If it's about something else, so 5 into 14, we can write it as a mixed number. 5 into 14 twice. The remainder is 4 over 5. For example, as a decimal will be 2.8. That's right, 2.8 or 80. So all these are acceptable, depending on what the problem is. So it's really simple to solve a proportion when you turn it into equations. So the numbers are not always easy and convenient like this, but when you put them into equations, we can find the solution no matter how complex the numbers look by following, can solve by following all the properties or the rules we learned about equations. So we learned them, and this is again another application of that. Finding missing numbers. So if you see a proportion here with the missing numbers, you can find a missing number using equations and cross multiplication.
That finding missing quantities exercise is the same thing that we use when we convert from a measurement to another. Let's say from centimeters to meters.
That's right. Yeah, that's right. We use the ratios also. For example, we can say, there's actually, yep, let me put that example here. So we know, for example, 1 inch or one foot is how many inches?
12 point something?
12.
Oh,
A
12.
foot is 12 inches. Let's say you have
5 feet?
maybe 5 feet. Yeah, let's say you have 5 feet and you want to find out. You don't know how many inches. So we can always cross multiply. So we don't know, so in 5 feet, we don't know how many inches, so we can cross multiply. So it's going to be 1 times x. 1 times x would be equal to 5 times 12. That's going to be x, and 5 times 12 is 60. So 5 feet is 12 inches.
Professor, you want to put 12. You don't want to put 12, you want to put 60.
60, that's right. 5 times 12 is 60. So that's one way. You can convert it with any units, but you have to have a base formula. You have to know that 1 foot is 12 inches and 1 pound is 16 ounces. And you have to have a base formula, base ratio. Based on that, you could convert anything else. Just like, for example, knowing the price of, for example, at a store, 3, 4, 7. So this is what you base every conversion or every ratio on. So you gotta have some basic formula. This is the actual price, for example. Then you can do the math. Let's say you want only one item, or you want more items. So you either divide both of these or multiply them. So you would know how much, for example, you need to spend. So that's how ratios work. The units may change. Could be anything here, money, miles, hours, whatever you're converting or you're calculating, but it's the same way. 2 ratios, cross multiply, solve them using equations. Let's do one with maybe some shapes. Let's take the same example. Let's say you have. So don't worry about the squares. Don't count the squares here. Let's look at the numbers. Let's say this is maybe 2 to 7, and this may be 5, and this would be x. So these basically, this is the same side. not equal, but one of them, this side was, changed it into 7. This side is equivalent to this one, but we need to find x. So if this goes from 2 to 7, this should go to where? Should go to what value? From 5 to 1. So we're going to have to write two ratios. Two ratios with arrows. So what are the two ratios, for example? What is a way or possible way to write two ratios? So one would be complete, a number to a number. The other one would be a number to x, for example. So give me two ratios based on this, on these shapes.
2 to 5.
Okay, so we can do 2 to 5. Would be the same as same
7 to
ratio as
x.
7 to x. That's one way to do it. Or we can do 2 to 7,
And
5
5
to x. Or you can do 7 to 2, x to 5. As long as we do both in the same direction. As long as we do both in the same direction, we can solve it. So for example, 2 to 5, so we can say the ratio of 2 to 5 should be the same ratio as 7 to x. Okay, so this to this would be the same ratio to this. Again, if you double, for example, this or whatever triplet, the other one should also change proportionally. And once we have your ratios with x somewhere, we just need to solve this to find x. So what do you do here to find x? Again,
2
Cross multiply.
times 2 times
Cross.
5.
It's the cross multiply.
that's right. So cross multiply. So once you have that,
2x equals 7 to equals 7 times 5. 2
that's right.
times
So
x.
start
2 times
always,
x.
that's right. Always start with a multiplication that has x. Even if x was here, for example, start with a multiplication that has x. In this case, this one. So 2 times x equals 7 times
5.
5. So this is 2x equals 35.
And
And of course,
35 divided by 2.
that's right, divided by 2. So x is 35 over 2. Or if we turn it into
15, 16, 17.
17.5, right? And there's got to be some unit here. For example, the unit is inches, whatever the unit is. So fractions are fine. Mixed numbers, decimals, all depends on the situation, but reduce it first. If it's a fraction, you can reduce it. And so these are what we call similar. We call these similar figures. They're not the same size. They're similar in size, in shape, but not in size. Okay, they're similar. So when two figures, at least in geometry, when we say two figures are similar, that doesn't mean they're identical or equal. One of them is a larger version of the other. So that's not congruent. If they were the exact same size, exact same shape, we call them congruent. But these are not congruent. We call them similar figures. Could also be triangles. One is bigger than the other. So for example, this is 3, this is 7. This could be x, and this is, for example, 11. Same thing, you can do two ratios out of this. Either 3 to x is the same as 7 to 11. You can do 3 to 7, x to 11. As long as you do two ratios in the same way, then you cross multiply. So we call these similar figures because they're not identical. They just have the same shape, but not necessarily the same size. Otherwise, it would be identical. Otherwise, it would be identical or congruent. So congruent when they're the exact same size, exact same shape. And a lot of times, these ratios are not, it could be in a word problem. So it's not always written like this. You could have a word problem with, if you can buy X items for this, how much would this cost, blah, blah. So that's when you need to use ratios. Let me give you, let's see some examples of that for word problems. Involving ratios. So I could say something like, if let's say 5 items cost, let's say $17, How many items can you buy with let's say, instead of 17, maybe let's say 9. How many items can $9 buy? Let me read that again. If 5 items cost $17, how many items can $9 buy? Again, no need to do the math in your head. That can be stressful. It can be confusing, and you may never find the answer. But if you know the steps, you just follow the steps. This is like using a calculator. You just turn it into ratios, turn the ratios into equation and solve. So you act like a robot or a computer. You just execute some actions, some commands, and you find the answer. It's like plugging things in a calculator. So you don't have to think too much. Just turn the problem into an equation, and the equation will do the work for you. Equation, cross multiply, and so on, you find the answer. So don't try to work it out in your head. It's not always convenient. Unless the numbers are convenient, for example, 5 items for, I don't know, for 10 items for 20 and so on. But sometimes the numbers can be not as convenient. All right, so this is our problem. Again, it's not written in a ratio. So we have to turn it into a couple of ratios and then solve the proportionality or the ratio. Okay, so let's turn this into 2 ratios. What's the first one?
Is X
17.
times 17?
5 and 17, and then
Right,
9
so
and
5 to
X.
17. That's right. 5 to 17. That's the actual, again, symbol for ratio, 5 to 17. Or I like to use arrows. It makes more sense. 5 to 17. And then another one.
X to 9.
9.
That's right. So
9
this
to
side
X.
here, that's right. We used items here to dollars. The other ratio should also be items to dollars. If you want to start with dollars, that's fine, but you got to do the other one also, dollars to items. Here, for example, if you want to do to 7, you have to do 5 to X. You can't do 2 to 7 and do X to 5. It's going to be mixed up. Do it in the same direction. For example, this to this, this to this, or 2 to 7, 5 to X, and so on. So do we know the?
No, you don't know. The items are X.
That's right. So it says here how many items. So we don't know the items. So this will be X. So X should go here,
X to
not
9.
here. That's right, because we do know the cost.
You have $9.
So the X could be here. That's right. So the cost is $9 here. Doesn't matter. I don't care what the numbers are. I don't care how complex they are. I'm setting up the thing, and later we'll figure out divide. We'll see if it's a decimal, mixed number, whatever it is. While we're doing now, just following the steps. Okay. That's basically just doing steps, and the problem will solve itself. We'll see those are our ratios. And what do we do next? So we have a missing quantity.
Cross multiply.
Equation.
That's right. So we're going to cross multiply. What's the first multiplication?
X
5.
times 7 equals 5 times 9.
That's right. So start with a multiplication that has X. Always start with it on the left side. It's not a big deal, but it's better. So X times 17. Then you have 5 times 9. So this is 17X. 5 times 9 is 45.
45.
Okay,
Then
good.
X equals 45 times 17.
That's right.
I mean, divided by 17, I'm sorry.
Even divided by 17. So X is 45.
2.64.
That's right. So again, don't worry about the exact value. Worry about the steps. Worry about the work and steps. The value, again, you can find later. This is the value. We can turn it into decimal. We can turn it into a mixed number, whatever the problem is. Since we have number of items here, right? An item has to be complete. So let's turn this into a mixed number. So number of items should be a whole. For example, you're buying maybe a fruit or a bottle of something or something that's a whole. So you can't split it, you can't divide it. So you'd know how many items you would buy, and you will probably have some change. So based on this, so the number of items, let's say it's an item that you cannot divide. For example, a piece of clothing. So you can't buy 2 pence and a half. You have buy a complete pair. If you don't have enough for the other pair, so you may buy either a pair or a multiple pairs or nothing. So how many items, for example, here we can buy with, well, with this amount?
2.
17 into 45 would be 2. That's right. It's not enough to buy 3 items, so 2. 17. What is the remainder here?
9.
9. Because, again, 45 goes into 11, or 11 goes into 45 twice, which is 34. So the remainder is not 9, would be 11. Right? So that's basically the number of items. So again, depending on what the problem is, if it's money, if you can get 2 decimals, here is items. So basically you say 2 items. So it's going to be 2 items and you'll have some money left, a little bit of change, not enough to buy another item. So basically 2 items. If it was the other way around, if we were missing the amount, we would get it to the nearest cent like this. We'll get it like this to find exactly, we would turn this, for example, into a decimal, 2 point something, 2 point. But again, all these quantities are correct and you can get it to whatever form you want it, mixed number, decimal, fraction, and so on. Okay, so that's an example of a problem. The word problem we can solve with ratios. The units may change. The units and the numbers might change, but the steps are the same. Write 2 ratios, cross multiply, solve every time.
Excuse me, teacher, can I?
Okay, go ahead.
Is this called similar figures? Because I'm confused.
That's right, similar figure.
So this is called similar figures ratio. Okay, this is not called ratio. What's the other one that matches? What's the other one called that matches? When you could do like both sides?
So these are similar figures because they're the same shape, not the same size. If they are the exact same thing, we would call them congruent. Congruent or identical, or same, exact same thing. But these we call them similar because one of them is smaller, but the shape is the same. But one basically is a proportional or bigger version of the other one. And this is how you find the missing quantity. Okay, so again, the units here might change. The units and the numbers change depending on the problem, but your steps don't change much. It would be 2 ratios, cross multiply, solve. Let me give you another problem, another word problem. Let's say, sure you see per miles and hours often in word problems. So if you're driving at a certain speed, let's say 60 miles per hour. 60 miles per hour, which means in each hour, during each hour, you drive 60 miles. Another symbol for this is miles per hour. Okay, that's the speed of a car or something. So miles per hour, that's the abbreviation or the acronym. And this is another way of writing it. So you're driving at 60 miles per hour. How many hours? Let's say how many hours. How many hours will you need to travel 150 miles? So again, we need to understand the problem. As we saw last time, the problem solving strategy. Always read the problem as many times as needed until you understand it. If you don't understand it, read it again. If you don't understand the problem, you won't be able to solve it. So like I said previously, understanding it is basically halfway through solving it. When you understand a problem, you're almost there. You basically 50% into solving that problem. Okay. So let me read that again. So if you are driving at 60 miles per hour, how many hours will you need to travel 150 miles? So again, try not to try to figure out the problems in your head all the time, even though it's a good thing, it saves time, but for now, try to learn the steps. Try to learn the steps, because when you try to figure out the numbers in your head, it might not always be convenient and easy. So you may end up again wasting time and not finding the answer. But this is the lazy way. When you do it with equations, it's the lazy way, which guarantees you an answer, an accurate answer. If you do it in your head, you wouldn't get details like this, decimal, and so on. So if you're driving at 60 miles per hour, how many hours will you need to travel? So with this type of problem, always try to turn it into two ratios. Two ratios, and the rest should be simple. So based on this, what is the first ratio?
Is 60 miles to 1 hour.
It's going to be 60 to 1. That's right.
And
That's what the
then
problem said.
150 to X.
Okay, so this side is for miles. Side is for hours. So 60 to 1. The other one, what are we missing? We're missing the hours, right? So we don't know. We don't know the hours. So we're going to call that X. So the hours should be under the hours. So 60 to 1. We do know the miles here, which is 150. And here, we don't know it, so we're going to call that X. That's it. Again, the same procedure every time. And what do we do now?
The equation, 60 times X
That's right. 60 times X would be 60X.
equals 150 times 1.
That's right. 60 times X is 6X, 60X. 150 times 1 is 150. And solve that for X.
X is equal to 150 over 60.
That's right. We're going to divide both sides by 60. Cancel these. X is this. We cancel this and this. 15 over 6. And reduce your fraction. Reduce it first. We can reduce it by
10.
Not by 10.
I mean,
Three.
that's what it is.
By 3. So 3 into 15, 5 times. 3 into
That will be 3.
3 into 6, twice, which is 5 divided by 2 is 2.5. And what is the unit again? What are we looking for here?
Miles per hour.
Hours. So 2.5 hours. What in minutes it would be? What is it? 120. In minutes. You can
Professor,
convert it into
question.
minutes. Mhm.
When I did the problem just right now, I didn't, how do you call this? I didn't make it less numbers. I didn't divide it by 3. I just did 150 over 60 and I divided it and I got 2.5. That's okay?
How did you divide it? Did you divide it manually? Did you use a calculator?
No, manually.
Manually? Maybe it's easier to divide.
I
this
just
if you
divided
can.
it because I thought it was easier to think in fractions.
That's fine, but yeah, but maybe it's easier to divide the smaller numbers. These cancel
Yes,
right
it
away.
is easier. It took me longer than it took you.
Exactly. So, and also not even that, reduce it again into 5 over 2. So I did this without a calculator, 2.5. I couldn't see it here. I couldn't see it here either, but when I turned it into this, 5 is easy to divide by 2. So 2.5 hours. So this is again good. If you want to plan a trip, so you go in, let's say from one point to the other, on a road trip from A to B, assuming the road is straight and everything is clear. So you could estimate, let's say, if you know the distance, if you know the miles, you could find the hours. If you know the hours, you could find the times. Usually you would know the miles. Let's say you're going from A to B and you know, for example, it's 100 miles away. A is 100 miles away from B. So if you're driving at 50 miles per hour, how many hours will it take to travel from A to B? For each hour you travel 50 miles, and you need to travel 100 miles. So how many hours is that?
I'm sorry, I didn't understand the question.
So you want to go from A to B, and you're driving at 50 miles per hour. This is, for example, your speed. So how long will it take you, or how many hours will it take you to go from A to B?
2 hours.
2 hours. That's right. 2 hours. This was easy, convenient, but it's not always this easy. We can always use this. If it was, for example, not 50, it was like, oh no, 63 miles per hour, and the distance here is, I don't know, 125 or 127. So it's probably not as easy to do it in our head. So, but we follow this, you find, for example, the time you can estimate. If you leave at some time, you can get there at a certain time, basically by using this. So you might be missing the hours or the miles. Turn that into a ratio, and you can easily find
Professor,
whatever you
I-
look up.
I was able to do it in my head, but
Mhm.
I mean, I just can't, I don't know, how did you, like, why 152x? Why not x to 150? I'm confused here. I didn't.
So
You know what
you
I
can
mean?
you can do, if you want to do from hours to miles, you gotta do the other one also in the other direction. So one side is for miles, the other side is for hours. If you want to put hours here, you're going to put the other miles there. So if you do x to 150, you'll have to do 1 to 60. So the hours go here and the miles go here.
Oh, okay.
Okay, has to be the same direction. It would still be the same.
So these are hours. Okay, thank you. Got it.
So yeah,
Teacher, can I ask you one question?
sure.
When you
go
were
ahead.
x equals 15 over 6 equals 5 over 2, how have we got this number 5-2? I'm confused.
So first we had 150 over 60. We reduced by canceling the 10 from the 10, so we got 15 over 6. 3 goes into both. So we reduced this.
You gotta find a number that could go into both.
Yes, what's that number that goes into both? What number goes into 15 and
Thank you.
so 5 goes into both. So this is 5 times 3. And 6 is basically 2 times 3. So we canceled the common number that goes into both. That's why we have 5 over 2 here. Okay, so this is what we did in the first couple lectures of the semester. We discussed fractions, simplifying, reducing, cross multiplying, all that stuff we covered in the very first couple of classes about fractions when we simplified them. That's where we got the 5 over 2. Okay, any other questions, everybody? Everyone, any other questions about ratios here? What are the problems? So they all pretty much work the same way. The units may change the numbers, but the steps are the same. This, and solve. Another thing, the last thing we will discuss. So we saw ratios, proportions. Let's talk about percents. Percents. They are basically, percents are a specific type of ratios. They're also ratios, but a specific one. Should be number 3. So a percent is a special ratio that always has a number. What's that number? Percent is always, it's a
100.
ratio.
100.
Exactly. So for example, we say 15%. as we saw before, we can turn it into,
15
we
over
say-
100.
that's right, 15 over 100. Or as a ratio, we say something to something. 15% as a ratio would be
15 to 100?
100. That's right. So a percent is basically a specific ratio without 100. Always 100 here. So percent literally means per 100. And we can solve all sorts of percentage problems by turning the percent into a ratio, and then we'll write another ratio with x either here or here, depending on what's missing. The formula is, so each percent, as you can see here, each percent we said is basically 15 over 100. In other words, a percent equals a portion. So we have something
Portion
out
of
of something.
100?
That's right, a portion out of a whole. So this is the whole, the 100%, and a portion of it. So that's what a percent is, something out of something. So portion is usually smaller than the whole. So this formula here, we can use it with equations, of course, to solve all percentage related problems. Always, if you have a percentage problem, you can write it this way. So percent n is basically equal to a portion over a whole. The whole for the first ratio is 100. So it's always something out of 100. So some of the questions you can solve is, for example, 20%. Of maybe 5. So 20% of 5. So whenever you have a question like this, 20% of something, last time we saw that, we said that we can just multiply them. We multiply the decimal of this, multiply 5. That's one way to do it. You can do 0.20 multiply 5. That's one way to do this. Or we can also use equations like the ratios, as we're going to see now. So we can turn this into this. Turn the problem into an equation with two fractions. What you want to do is you take the fraction, the percentage, you turn it into a fraction right away. So 20% is 20 over 100. And then what you do is you got to figure out what's missing. So we have 20 over 100. Then you have portion over whole.
Move the point to the left.
5 is the whole, so it goes under.
That's right. So portion over whole. So 20% of, this is the whole number. And we're looking for a portion of it, 20% of it. It's less, it's smaller than 100, so it's less. It's a portion of this. So this is the whole number. It goes here.
And then the percentage is x because we don't know it. That's what you want
So that's right. The x or the percentage, we don't, I mean, the portion, we don't know it. So we're looking for a small portion of 5. So 5 is the bigger number, the whole number, and we just want a piece of it, a small portion, which is 20%. So in this kind of question, you put the x here. Sometimes the x can be here, or it can be here, it depends what's missing. So now, once you write this is basically like writing two ratios. It's the same as saying 20 to 100.
That's what I did just now.
And x to 5. That's right. So this is the whole. This is also the whole. So 20%. Then we were looking for the equivalent of 20% out of 5. So we can do it this way, turn both into ratios. First into a ratio, and then the other one, depending on what's missing. If you're missing the whole number, it should be under the 100. If you're missing the portion, the x should be here. Either way is fine. Then we solve this just like we did before. How do we solve this again?
That is
20 times 5 and x times 100.
That's right. That's right. Start with the multiplication that has x.
Yes,
Okay,
100
cross multiply.
times x equals 5 times 20 or 25 times whatever.
That's right, 20 times 5. So once you make it into an equation, solve it the same way we did a bunch of times. 100x equals
100.
100. Then we
And then
divide by,
It's a 1 by 100.
that's right, divide by this 100, divide by this.
So x
Cancels.
is equal to 1.
X
So
is-
20% of 5 is 1.
Exactly. So 20% of 5 is the whole number. So 20% of it, just a piece of it, is 1. So 1/5. That's in other words, this is 1/5. 1 out of 5, but 1/5. So remember, it means 20%, 1/5. Of course, 50% means half. 1/4 is a quarter, or 25%, and so on. Some percentage are simple, but others are not. So again, 20% means 1/5, 1 out of 5. What's 25% again? What is the word?
A quarter.
That's right. 25 5 of something means a quarter. Of course, 50% of something means
Uh-huh.
half. So just split it in half. If you said, for example, what's 50% of 10? Just going to say 5. But if you do it this way, you'll find the same answer. 25% is a quarter. What about 75%?
A third?
No. It's 3 of
A
these.
fourth.
3/4.
3
Oh my
quarters, yeah. A third is what? What is a percentage of 1/3? A third is 33%. A third of something means exactly 33%. So these are pretty much pretty easy. You can do these most of the time without, involving any of this. But sometimes it could be 17% of something. It doesn't have a name, but we need to know how to do it, and this is the way to do it. Okay, any questions, everybody, about the percents so far? Everyone, any questions about any of this?
No questions.
No question.
Okay, so again, this is the main formula that solves all the problems. Every time you have a percentage problem, write it this way. The x, just like the ratios, could be here, here, or there, but there's always 100. And once you figure out what to put the 100, cross multiply, and you need to understand the problem to put the x in the right place. It's important. You got to understand what's missing. Is it the whole or the portion? Let me give you another example. So let's say let's say 3 is 25% of what number? You might be able to figure it out easily. This is not a difficult one. You can probably do it. But if not, it's not a problem. That's why we have the equation for, so we can solve all the problems, the easy ones and the difficult ones. So here it says 3 is 25% of what number? It's basically backwards of this. Here we were looking for 20% of 5, which is 1. We said, now we have the 1, but we say it is 20% of what number? In this case, we don't have this one. If that makes sense. Yeah, 25%.
Is it 12?
It is 12, that's right. That's 12. So these convenient ones can sometimes be easy to figure out, but if not, we can always use the percentages. So
I would say 3 is to 100, what x is to 25.
3 is 200, x is 20. That's a little bit, okay, let's put it in a simpler way. So again, this question and this question, they're different. This one is straightforward. What is 20% of 5? 20% of 5, but this one is backwards. 3 is 20% of what number? Basically, we have the answer here. We have the answer. 25% of a number is 3. So we want to find that number. So what are we missing here in this equation? Are we missing the percentage, the portion, or the whole?
You're missing the whole.
The whole.
We're missing the whole. Exactly. So we're going to turn. So make this into a fraction right away. If you have percent, make it a fraction right away. This is 25 over 100. Or you can make it a ratio like this. So 20% over 100 equals what? The other.
X over 3.
So what are we missing again? We're missing
It's 3 over x.
We're missing the whole.
3 over x. So we're missing the whole. So the whole is here.
Plus-
So you can use ratios, or you can just use fractions. Turn the percentage, if you have it, turn it immediately into a fraction. On the other side, figure out where to put the x. You will have one number, and you need to put the x where, depending on what's missing. Okay, so notice here that we put the x here because this is a straightforward question, 20% of 5. But if you going backwards, 3 is 20% of one number. That's how you know you're missing the whole. And again, cross multiply 25 times x, 3 times 100 is 300, and divide by 25, divided by 25. Okay, so what is that equal to? X is, if you do the math here, 25
Professor,
into,
I am very confused right now.
okay, so again, we're missing the whole here. Here we're missing the portion. Here the whole is missing. 3 is 20% of what number? So we don't know that whole number. Okay, so again, that's why the question is, it's important to understand the question before we put the x. This is straightforward, 20% of 5. But this is basically backwards. We do have the percent, we do have the smaller number. 3 is 25% of what number? Meaning the whole. We don't know the whole. So that's why we put the x here.
So I have
Not
to
here.
see it, when I have a percentage, I have to see, oh, okay, I got it, thank you.
Okay, so have to put the x, and 25 into 300, that's 12 times. So that's the actual number. So it says here 3 is 25% of what number? It's 25% of this number. So 25% of this number, what a quarter of it, a quarter of 12 is 3. So that's important. Again, as we said last time when we solved the word problems, make sure you understand the problem. Read it a few times, know exactly what's missing. If you don't know what's missing, obviously you wouldn't know how to find it. So you need to know what are you looking for first, whether it's a portion, a whole, or a percent. So be careful with these questions about percents. They can be a little confusing. So here we were missing the whole. We were missing the portion here. The last thing is, see what happens if we don't have the percent. Maybe here we had the percent, we turned it into a fraction, but you may not have it sometimes. For example, we may say 4 is what percent? What is 1% of, for example, 20? This is not too difficult to do without. You can probably see it. You can probably figure it out. 40 is 1%.
So hold on. Oh, so you're trying. So 20 is my whole, right? And we're trying to find a percent.
Exactly. So we don't have the percent. So that's the key thing here. When you don't have the percent, you will clearly see it. It will say what percent or what grade or something like that. So we clearly know what's missing now. So we don't know the percent. So that's basically the x. So we don't know it. When we know it, we turn the percent into a fraction. If we don't know it, we put the x over the 100. So we don't know what the percentage is. So we're going to say x over 100. okay? So x over 100. If we don't know the percent, and we should have the other ones. Only one quantity is missing. It can't be two missing at the same time.
It should be 4 over 20, right?
4 over 20, that's right, 4. That's our whole number. This is a portion. So, so that's another way, okay? That's in the third way of type of question. So the x could be here, could be here, or it could be here. Again, with the percentage, most of the time it's straightforward. You will say what percent, what grade, for example, in case you calculating the grade. But with the other two, again, be careful. Make sure you understand what's missing, the whole other portion. Once you get the equation, this is the most important part. The rest is simple. Solving it is easy. You just gotta get the right equation.
Making it radius, what I did was 20 is to 100, what 4 is to x. So it's basically the same thing.
Yeah, as we
Because
said
to me,
earlier,
it's
so we
100
can,
in this
but
one.
here maybe we said x to 100, 4 to 20, or you can say 100 to x, 20 to 4. You may even say 20 to 100 is the same as 4 to x. It doesn't matter where you do it. For example, if you have 2 and 4, and let's say if we triple this, it will be 6, this will be 12. You can do it any way you want. You can just say 2 to 4, 6 to 12, or you can say 2 to 6, 4 to 12, or you can go backwards. You can say 12 to 4 is the same as 6 to 2, or 12 to 6, 4 to 2. It doesn't matter, but at the end of the day, the cross multiplication.
Where did you get the 6 from?
This is just I made up this problem here.
Oh, okay.
Just doubled. I think I doubled both quantities, or
So
tripled them
if
times 3.
X is the percent, then 100 is the whole, then how can we call the 4 and the 20?
The portion on the whole. Portion on the whole.
A portion.
One? One out of something.
Okay.
So 4 of 20. So 4 out of 20. And again, always the whole portion of the whole goes here, portion at the top. 100 is the whole of whatever percentage. If we know it, you write it down. If we not, we put x. And the rest is simple. X times 20 is 20x. It's 400. And divide by 20, divide by 20. Cancel these. X cancel a 0 against the 0. What's left is 40 by 2, which is right. Is there something is wrong? 400. Like x times 20 is 20. 400. What is that equal to?
20.
20. 20 what? What is
%.
percent? That's right, because we're looking for percent. It says what percent? So 20%. Just a coincidence that 20 here is also 20, but they're not the same. It's different. This is the whole here. This is a percentage. Just a coincidence they ended up equal, but they don't always end up like that.
How did you get 20?
Dividing 400 over 20.
So first I cancel the 0 against the 0.
Oh, okay.
I'm left with 40 by 2. 40 by 2 is 20.
Oh, okay.
Okay. Or you can do it the regular way. Okay, so this formula again solves all the percentage problems as long as you put the x in the right place. Now we have this shortcut, but this only works if you have a question like this, the red question. You can multiply the decimal by the number, but it doesn't work for this. It doesn't work for this. That's why I prefer you stick to one formula that solves all the problems. You just need to understand the problem, put the x in the right place. Okay. Everybody, any questions about the percents here? About the
Professor?
formula? Is that sorry? You're breaking up. Whoever is trying to speak, your audio. The audio is breaking up. Can't hear you. Connection problem, I believe. Okay, so again, everybody, please let me know if you have a question. Let me know if you have any questions here. If not, I'll give you maybe a couple of questions to practice here. All right. All of these. Let me say, for example, 11 by 4, maybe 6 by, oh no, 3. Some random ones I made. See if this is proportional. Find, for this one here, find x. So you have x to 7, 5 to 12. And maybe what's 13%? And 5 is 30%, or some random percent, it doesn't matter. It's 27% of what number? Okay, so these are pretty simple. Again, if you know what you're doing, they all involve cross multiplying. Here you already have the ratios. Here you need to come up with the ratios first. And again, same thing we did over and over again. Give you a few minutes to do this. Okay, give you what, 8 minutes or so. Okay, so I'll check with you in a few minutes. We go over this together. I'll be back. Everybody, let's go over these problems. I know some of you have class after this, so let's go over this. What is the answer here? Yes or no? First one.
No.
No.
That's right.
No,
If you multiply, if you cross multiply, it would be 33. Not equal to
and
24.
24.
So are they proportional? The answer is no. To find x again, what do we do here? Cross multiply, right? X times 12, that's 12x equals what?
35.
5
35.
times 7, 35.
5 times.
Okay, what is x equals to? If we divide by 12, it
5
would be
divided by 12.
35 over 12.
over 12, and that's the fraction. You can reduce it. I mean, you can write as a mixed number, as a decimal, depending.
Makes
But
it
this can
is
reduce.
2. And then 11 over 12.
11 over 12.
Okay, that's good. What's 13% of 25? What are we missing here? The portion or the whole? 13%
Whole.
of 25.
A whole
Missing the
is
whole.
fine.
Okay, and turn this into two fractions. What's the first fraction?
Portion.
13 over
13 over
13
100
Okay,
equals
the other
x
one?
over 25. I mean 25 over
over 25.
5 over x.
Now the whole is 25. So we're looking for x
Oh,
proportion.
okay.
Okay,
I put
what is
it-
x equal to after all? What is x equal to if we cross multiply and solve?
325.
325, that makes sense. So it's a small portion of 25, a little bit of 25, that makes sense. The next one here, what's
20 is,
missing?
oh, déjame.
What is missing here?
Oh,
The whole. So we're missing the whole, so x is gonna be here. And this fraction, of
27
course.
over 100.
Okay.
5 over x. And then
It's fine.
27. 5.
27
5.
x equals 100.
That's right. So once you set up the equation, right, cross multiply it. Multiply these two and these two. What is x equal to?
Equal is equal 500 over 27. And I stop there.
I
5 is
I do stuff
27% of what number? 27%. No, it doesn't make sense. So 27% is about a quarter. So 5 is a quarter of what? About 20 something, 19 or something like that. It's got to be around 18 or 19, I believe.
18.5.
18.5. So that's right. Okay, again, just cross multiply and you'll find this. Same thing here, cross multiply and divide. The important thing is to get the equation, the ratios. If you have the ratios, cross multiply. If you don't have them, that's pretty much it. Okay, as always, you'll find this recording on Blackboard. You can rewatch it, review your notes before you do the homework. So it's going to be some homework, new homework posted. So check the Blackboard.